So this is the general equation for the combustion of alkanes. So it's not compulsory, or let me just say you are not required to memorize this equation. There's a way to balance this kind of equation without memorizing this. The method you adopt is just to balance oxygen last, lest the oxygen atom be what you balance last. Let's have a look at a simple example where we have methane react with oxygen to give us carbon dioxide and water. So when you're balancing, as I said, you will balance oxygen last. So we have one carbon atom, two hydrogen atoms here, two hydrogen atoms. So and then we have oxygen now. So how many oxygen atoms do we have here? We have two here, and then we have only one here, making three oxygen atoms. But here we have two oxygen atoms. So how do we balance this equation? To balance this equation, I think there's something wrong here. I wrote CH2 instead of writing CH4. Okay, so let's look at it again. Carbon is balanced. Hydrogen 4 here, we have only 2, so we put 2 here. By putting 2 here, so it means hydrogen is balanced. And then we look at oxygen. Is oxygen balanced? We have 2 here, and then we have 2 oxygen atoms here, so making 4, so we have to put 2 here. So oxygen is balanced. Now, so let's look at another example quickly. Maybe we have C3, H8 plus O2 to give us CO2 plus H2O. So 3 carbon atoms, so we put 3 here. And for hydrogen atom, we have 8 hydrogen atoms here. And then we can put 4 here. That is, hydrogen is balanced. So oxygen now. Remember I said you will balance oxygen. Why do we balance oxygen last? Because it is not a compound, it stays on its own. So you can adopt this method for any other equation when you have an atom or a molecule that stays on its own without combining with anything. Balance it last. It makes your life easy. Okay, so we have how many oxygen atoms? Here we have 2 times 3, 6 oxygen atoms here. And then here we have 4. So 4 plus 6, that is 10 oxygen atoms. So we can put 5 here now. And so that is balanced. So that is one of the reactions. Remember, this is the product of this reaction is carbon dioxide. Sometimes your products can be carbon monoxide. When the product is carbon monoxide, it means that combustion is incomplete combustion. When you have carbon dioxide, the combustion is a complete combustion. Incomplete combustion because it happens in a limited supply of oxygen. If it happens in an abundance of oxygen or in excess supply of oxygen, that will give you complete combustion when you have carbon dioxide as your product instead of carbon monoxide as your product. So let's look at another reaction of alkane. So I'll make this one number 2, and this is halogenation. Halogenation. So this one is a form, because we are going to meet another halogenation reaction. So this one is a form of substitution reaction. It's a free radical substitution. Because another one we are going to meet later is not going to be, that halogenation will not be substitution, it's going to be addition reaction. So, in fact, I may not even call this one, okay, let's call it halogenation, because majorly this halogen, the common halogen that undergoes this kind of reaction is chlorine. So sometimes they can call it chlorination or substitution with chlorine. So they can call it that way as well. So let's just go. So it's just what you need to understand majorly here is it is a form of substitution reaction. This reaction we want to describe. So we have RH. That is our alkane. So remember, R is an alkyl group, like CH3 or C2H5. You know, if you have CH3 bonded to H, that is invariably CH4. Or you have C2H5 bonded to H, that is C2H6. That is this is methane and this is ethane. So just for the purpose of this reaction, to make it easy for you to understand, that is why it is written this way. So X2, X represents our halogen. So it can be chlorine, it can be bromine, it can be iodine. Okay, so let's go. So we have this. This reaction is catalyzed. It happens in the presence of UV light. You have to mention it. So this one occurs in the presence of a UV light. So if you don't indicate this, you may not get the total mark. Okay, and this is a form of photochemical reaction. Can you think of another photochemical reaction? There's one that is we are familiar with very well. That is photosynthesis. It's also catalyzed by heat, UV light. Okay, so this, you know, we call it substitution. You remember, substitution means replacing A with B or replacing B with A. So we are replacing the hydrogen atom here with one of the halogen atoms here. So let me write this one this way. So let me just leave it this way, and then I will indicate that it is like this. X bond to X. Sorry, X bond to another X to give us X2. So how does this reaction occur? So it's going to give us one of the X will be the H will be substituted with one of the X here, that is one of the halogens. So we are going to have RX plus we have only one X left, and then we have, so it's going to be HX instead of X2. So a very good example of this is methane, CH4 rather, plus instead of X, let's use chlorine, Cl2. So UV light. So it's going to be C out of 4 hydrogen, one will be substituted with chlorine. So it's going to be CH3 Cl plus H, we have one Cl left, so HCl. So this is the reaction, and this is chlorination of ethane. So our reactant, our product here is going to be you can call it chloromethane or 1-chloromethane. Chloromethane. So remember, it is also possible for this if you have excess chlorine in the reaction vessel. So this will be further substituted one of the hydrogen here until you don't have any hydrogen left. For example, you can have CH3 Cl plus further Cl2 and then UV light. So you're going to have CH2 this time around and then Cl2. Your product will still remain HCl, as in the other product will still remain HCl. So here you have dichloromethane here. So this is dichloromethane. If this one goes again, you're going to get trichloromethane until all the hydrogen atoms are substituted, where you're going to have tetrachloromethane. So another reaction of alkane is what we call cracking or pyrolysis or cracking. So this one is, it involves heating alkanes to very high temperature without oxygen. This reaction will, this heat will break, what do you call it? It breaks alkanes it breaks it down into smaller alkenes, that is big alkanes to smaller alkanes and alkenes. I will write it, you're going to see. So it's a very reaction in the petroleum industry, this reaction, because it's used to give us more hydrocarbons, that is more petroleum products. Okay, so let's look at, I can say, I can write big or large alkane, when we crack it, so it becomes small alkane plus alkene. This is important. It can be more than one alkene. Actually, it can be two alkenes. It can be two smaller alkanes as well. So let's have a look at a reaction where we have C10 H22. This is the cane. So when it is heated, this reaction happens in the presence of catalyst. Sometimes you can use heat only, sometimes you can use heat and catalyst. When you use heat and catalyst, that is catalytic cracking. If you use only heat, we just call it cracking. Okay, so heat, let me add catalyst as well. So we are going to have, so a must, I use, this is important, a must, a product, because they may ask you to write this kind of reaction. It is easy, just write an alkene first. An alkene that is smaller than alkane, that smaller than this larger alkene that you started with here. Put an alkene here. It can be C4 if you like. It can be C4H8. So the remaining atoms of carbon and hydrogen will give you the smaller alkene you are expecting. So, you know, we have C10 and we have used 4 here out of the 10. So we have C6 left. So you don't need to count the hydrogen. We are talking about alkane now. So if it is C6, it's going to be H14. If you count, everything will correct. 6 plus 4 for carbon equals 10. 8 plus 14 for hydrogen is 22. So this is fully balanced. If you like, it can be C5H10. Just ensure that you write your alkene first. So what you have left is going to be your smaller alkane. So it's going to be C5H12. So if you add them together, 5 plus 5 give us 10, and then 12 plus 10 give us 22. So that is how to write the equation for cracking of alkanes. And this one ends the video series regarding the alkanes. So we're going to move to the next, which will be alkenes. So alkenes is an unsaturated hydrocarbon. We're going to see that as we move on. Thank you so much and see you in the next video.